Alright, ladies, so this is our last video involving solving quadratic equations. We're going to be using a method called completing the square. We're going to solve by completing the square. So let's first talk about what completing the square means. So what completing the square means is it's a method for converting x squared plus bx, so this binomial expression with quadratic term and a linear term. X squared is quadratic, bx is linear, and we want to turn it into a perfect square trinomial. So I'm taking x squared plus bx, and I'm making it x squared plus bx plus something squared, right? That's the form of a perfect square trinomial, right? Perfect square, and this is going to be the product, twice the product of the square roots of those. Well, what is this term here? Well, I'm just going to tell you it's going to be b over 2, right? This b divided by 2, and then we're going to square it. And that's going to be this constant term that makes this a perfect square trinomial. But why b over 2? Well, let's take a look at an actual example, right? So if I look at x squared plus 8x plus 16, this is a perfect square trinomial. How do I know it? Remember we talked about this, right? Well, I know that this is a perfect square, right? I know that x squared is a perfect square, and I know that 8x is twice the product of the square root of x squared, which is x, and the square root of 16, which is 4. So what have I done to get 8, right? 8 is equal to the square root of 4 times 2. So I've taken the square root of 4, and then I multiplied it by 2. So if I want to go back to 16, right, what is 16? Well, 16 is going to be equal to, and I'm starting from b, it's going to be equal to 8 divided by 2, right, squared. So it's going to be 4, and then I'm going to square that to get to 16. So this is exactly what we're going to do to complete the square on an algebraic expression. That's where this b over 2, 8 over 2 squared comes from. Okay, so let's look at some examples of just completing the square, right? We're just going to complete the square on each of these. Number 1, so complete the square on x squared plus 6x. So I need to add something in here, right? So I'm going to take 6 and divide it by 2 and square it. 6 divided by 2 is 3, and 3 squared is 9, so this is plus 9, right? And that would equal what? X plus 3 squared, this number here. Okay, number 2. So this is pretty straightforward and simple, hopefully. Let's do x squared minus 9x. Okay, now I never said that, b had to be an even number and nicely divisible by 2. It's okay, we can still do this, right? This is 9 divided by 2 squared. Well, what's 9 divided by 2 squared? Well, we're just going to square each number. We're going to do 81 over 4, and that's it. And we add that to the end of the expression, and now we have a perfect square trinomial. And if we wanted to factor it, it would be x minus, because this is a minus, 9 over 2 squared. Okay? Next, we'll do a couple more here. X squared plus, let's move this up a little bit, 12x. Again, we're going to take 12, we're going to divide it by 2, we're going to square it. 12 divided by 2 is 6 squared, which equals 36. So that goes here, and that would factor to x plus 6 squared. And last one, I'm factoring because we want to use that at some point to solve equations, right? Last one, x squared minus 18x. Again, we're just taking 18, dividing it by 2, and squaring it. 18 divided by 2 is 9. 9 squared is 81. So this is plus 80, plus 81. and that would factor to x minus 9 squared. Okay, remember, notice that the minus always matches the minus in the binomial when we factor. The plus always matches, the minus always matches, and there we go. Okay, so that is completing the square. So now let's see how we can use that to solve equations. All right, let's see how we can use that to actually solve some equations. All right, number 1. 3x squared minus 12x plus 6 equals 0. And you're saying, Mr. on the front of that, and we didn't complete the square with numbers, that have a 3. Well, you've got to look at an equation and see if you can simplify it somehow. I know that negative 12 and 6 all have a factor of 3, so I can actually divide everything by 3. Notice I'm even dividing this because it's important that we, do everything on the left and the right side. So when I do that, I get x squared minus 4x 2 equals 0. Now, this actually is not factorable. This because a product of 2, the factors of 2, will never give me negative 4. So this is where completing the square comes into play, right? When I can't factor this, then completing the square comes into play. I am going to move, first step, I'm actually going to move the negative, the 2, I'm going to move it. And I shouldn't have put can't factor here, because what I'm going to do is I'm going to subtract 2 both. Sorry for the glitchiness on the film. I don't know what's going on. Keep everything, lined up. Okay, so x, and I'm going to just leave a little space because we're going to complete the square right here. A little space because I want to complete the square. So what am I going to do? I'm going to take 4 divided by 2 squared, which equals 2 squared, which equals 4. And I'm going to add it to the other side. That's really important. Add something to one side of the equation and not to the other. So it's important that you add to both sides. With x squared minus 4x plus 4 equals. And then, again, the reason we completed the square is to factor this expression. This is now a perfect square trinomial, and it factors 2 from here. Squared equals 2. Take the square root of both sides. Now it goes back to solving by taking square roots. So that gives me x minus 2 equals the positive or negative. So positive and negative root of 2. So we're going to set this up to 2 equals the square root of 2, and x minus 2 equals the negative square root of 2. And we're going to add 2 to both sides. I'll do it on both equations here. Now, add 2 to root 2, or I can't do 2 to negative root. I can't just add it, but we're just going to leave it at 2 plus the square root of 2, and we're just going to leave it like that. Or x equals the square root of 2, and we're just going to leave it like that, right? This is the exact value, so we don't have any decimals or anything. I could write this one more way to simplify it even a little bit more. We could use the negative symbol here as well, and all 3 of those are acceptable ways to answer this equation. Okay, let's do another one. Number 2. I really hope that my writing and speaking are lining up enough to make this work. Alright, next one. X squared plus 6x minus 3 equals 0. So again, this is not a factorable equation, right? I can't take the product of negative 3, and there are no factors of that have a sum of positive 6. So we're going to complete the square. I'm going to add the 3 to both sides. And again, leave some space on the left here to add that constant in. We're going to take and complete the square. We're going to take 6 divided by 2 and square it. And that's going to be 3 squared, which is 9. So I'm going to add 9 here. And I'm going to add 9 here. So what I have is a perfect square trinomial, x squared plus 6x plus 9 equals, and 3 plus 9 is 12. Okay, now don't go subtracting the 12 and trying to factor again, right? We're just going to factor this. X squared plus 6x plus 9 factors to x plus 3 squared equals 12. And we're going to take the square root of both sides. That's going to be x plus 3 equals the positive and negative square root of 12. And before we continue, I want to simplify, right? I can recognize, and you should recognize, with numbers that are even or bigger numbers, you really want to make sure whether or not you can simplify this. And I can, because this has a factor of 4 in it, which is a perfect square, and a factor of 3. So this is the square root of 4 times the square root of 3, which equals 2 times the square root of 3. So what I have here is x plus 3 equals the positive and negative square root of 2, equals positive and negative 2 times the square root of 3. And then again, we're going to set up sort of two equations here, right? X plus 3 equals positive 2 square root 3, and x plus 3 equals negative 2 square root 3. And when I subtract 3 from both sides in each equation, I'm going to get x equals negative 3 plus 2 root 3, or x equals negative 3 minus 2 root 3. Again, these are acceptable answers, perfectly acceptable, or you can write it in one expression as plus minus 2 square root 3. Okay? All right, let's do a couple more here, just a couple more. I just want to make sure you get enough practice and you see me do this enough times. Okay, just a couple more here. Number 3. 4x squared plus 10x minus 3 equals 0. Okay, so again, we can't factor this, and you do see, something on the x squared here, factor. So we're going to talk about what we need to do with that. But first things first is let's just get this left side variable terms by themselves. We're going to move that constant over to the other side. Okay, now I want to get rid of that 4. And the only way to get rid of that 4 is to divide it. Divide everything by 4. Okay, so what does that give me? X squared plus 10 fourths x equals 3 fourths. Well, let's simplify this again, actually, because 10 fourths can be reduced. And it's really important that we reduce our variables when we can. Okay, so now I didn't quite leave myself enough room here, but I need to complete the square here, right? I need to complete the square using 5 over 2. So that's 5 over 2 divided by 2 squared. Okay, what's 5 over 2 divided by 2? Well, we're dividing fractions, basically, right? We could think of this as 2 over 1 if you'd like. What does that become? 5 over 2 times 1 over 2, right? We divide by the reciprocal. The reciprocal of 2 is 1/2. And we square it. Well, that equals 5 halves times 1/2 is 5 over 4. And we're going to square that, which is 25 over 16. So that's what we're adding, plus 25 over 16. Put the equal sign here so we can just make sure to keep it separate, plus 25 over 16. So we get x squared plus 5 over 2x plus 25 over 16 equals, and 3 fourths plus 25 over 16, that ends up being 37 over 16. Okay, you can do that on your calculator if you like. All right, how do we factor this? Well, it looks complicated, but we already have that b term, 5 fourths. That's the one being squared, and that's the one in our binomial. It's x plus 5 over 4 squared. So factoring this, even though there's fractions and it looks complicated, we already know what that term is going to be. It's right here. 5 fourths squared equals 37 over 16. We're going to take the square root of both sides. So here we're going to have x plus 5 fourths equals the positive and negative square root of 37 over 16. Now let's simplify that. Remember that 37 over 16 can become the square root of 37 over the square root of 16. And since this is 4, it's the square root of 37 over 4. So this is x plus 5 fourths equals the positive and negative square root of 37 over 4. And then we're going to subtract. I'm going to not do this separately now, right? We're just going to do this in one fell swoop. Subtract 5 fourths from both sides. And what that's going to give us is x equals, I'm just going to put it in front of our radical term. And we'll do the plus minus square root of 37 over 4. And that's it, okay? We can't combine these because of the radical, okay? We can't combine these because of the radical. So we're just going to leave it just like that. Okay, one more, just quick one. This one is actually not too bad at all. X squared minus 12x plus 7, equals 0. So again, right, we want to move the 7. We can't factor this. That's the first one, is check for factoring, but since we can't, the 7, move it to the other side. We're going to take 12 and square it. That's going to be 6 squared, which equals 6. So we're going to add 36 there, and we're going to add 36 here. Make sure, again, it's super important. I did it in every equation, right? Add it to both sides. This is x squared minus 12x plus 36 equals, this is 9. We're going to factor this as a difference of, a perfect square. Try minus 6, minus, and there's your 6. We're going to take both sides. So x minus 6 equals the positive and negative root of 29. 29 is a prime number, meaning, right, it has no factors other than 1. So that's as simple as it's going to get. We're going to add 6 to both sides. So x minus the square root of 29. And that's it. That's solving by completing the square. So please let me know if you have any questions. Take care.